So myself and Mr. Jim Brittell, who works in design and construction as a project manager on the UCI campus, will be discussing green building today with you. He's also a lead AP, and so just as a first question, how many people know what a lead AP is? Okay, good. A small amount. Good. That's good, because then we have a lot to teach you. So as some of you may know, I used to work for a brief period at the U.S. Green Building Council, and they are the people who are continually developing different versions of and upgrades to the LEED rating system for green building. And LEED means Leadership in Energy and Environmental Design. And so a LEED AP is an accreditation that you can get as a professional if you want to build green buildings, you want to be a technical expert at green building and apply to get this plaque on your building. And there's other kinds of LEED APs that you can get, and for students, actually the best version, if you guys are interested at all in coming any part of the green building sector, the LEED Green Associate is a good entry-level introductory thing that you can put on your resume and say, I know the basics of green building, and it's just a nice little thing to have. And so, as I was saying, they're the people who developed the LEED rating system, and so while I'm not a technical expert, I don't have a LEED AP like Mr. Brittell. I worked in the marketing and education department there in the DC office. And so the slides I'm going to be presenting are sort of about the general concepts of green building and not, like nitty-gritty details. So the engineers in the audience, talk to him. Traditionally, the history of green building is about energy efficiency. So after the first oil crisis in the 1970s, a lot of people wanted to make energy efficient buildings. And so these buildings, though, kind of look like this. I mean, this is an example. I think that it might be, it's not what I just Googled, a building that looked like it had no windows, because literally, energy efficient buildings back in the day were windows, like some people still in the industry will talk about this. If they're just focused on energy efficiency, it's like, okay, no natural light, try to, we'll minimize the HVAC and we'll just try to make it as efficient as possible. But this led to, kind of not such happy places to work. So sick building syndrome, buildings that weren't as pleasant places to be in. Sick building syndrome is actually defined as the used to describe situations in which building occupants experience acute health and comfort effects that appear to be linked to time spent in a building, but it can't be directly linked. So, I mean, an example of this, if you've ever been in a building that just kind of like, I used to work in an environmental planning department, and the office area that we worked in just like had this like thickness in the air, and it was like mildewy, and it was, it was kind of crummy. And, while you couldn't directly relate it to the illnesses of the people in there, 3 people out of 20 developed, and this is kind of sad, a form of cancer in this area over the course of 10 years. And so sick building syndrome is not, there's a direct cause from the building contaminants on the person, but I could have easily called that space a sick building because it just had some issues with the toxins that were coming in the ventilation, lack of ventilation. So obviously green building, as you guys were mentioning though, is not all about energy efficiency. So we don't need to sacrifice comfort, safety, or health in order to have a green building. We can have an economically efficient building, one that promotes occupant well-being and is responsive to the environment. So it's not all about energy efficiency. And as usual, as with most things in this course, green buildings are a great example of a very robust triple bottom line. So it's probably one of the best examples if you had to talk about something in the sustainability world that displays all 3 aspects of sustainability. And we talked about some of the social ones, and we'll come back to those too. So these are the core concepts I'm going to be touching on today. Renewable energy, and these are kind of developed actually, they came out of a publication that the U.S. Green Building Council and a nonprofit called Second Nature came up with in their education departments about sort of core concepts that we think students would need to know about in green building. So renewable energy and energy efficiency, the interconnectedness between the built and natural environment, how the building impacts health, how green building, as we were just talking about, is a model for financial security and profitability. Systems thinking, so how is systems thinking used in green building? I know we are always forcing you guys to work in groups, but you'll understand maybe from this presentation more also how, especially in the environmental world, you have to work with different kinds of people in different disciplines. And then rating systems, how do you actually say that a building is a green building? And then how this has become sort of an industry driver, like how did this catalyze become a movement? I have some cool videos to show you about that. So, but to step back for a second, why is green building important? Energy prices have been increasing for numerous years, this with coal, natural gas, crude oil, and this ends in 2008. But as we all have been seeing lately, obviously gas prices are still going up, energy prices are going up. So green building is something that can help with this. And so U.S. energy consumption, and this is broken down by sector, is generally, can be grouped into these three areas. Buildings accounting for 39% of energy consumption. And some people think that's even a conservative estimate. Some people say it's 47%, so half of U.S. energy consumption. It's a huge, huge amount. Transportation is 32%, and industry, industrial-related energy use is 29%. So while this is kind of a nice, neat picture of broken it down by sector, a building is obviously a bit more complicated, and each of these elements has much more complex processes going on. So there's a lot of different impacts beyond energy, too. The environmental impacts of a building. There's can be clumped into 4 areas. So the impact that buildings have on the environment, 12% goes water use, CO2 emissions is 40% almost, waste output is 65%, and 71% of electricity consumption in the US comes from buildings. So those of you, especially on the smart grid teams, see how important electricity consumption is. And even every individual in this class, I know Professor Matthews is always talking about how important it is for us to be doing individual lifestyle changes. If you get your parents to buy an Energy Star appliance, you are helping, target this electricity consumption. It's a very important thing. Never underestimate it. And so green buildings, how can we help with these things, right? So we just saw 12%, 39, 65. And then, so energy use, we can reduce up to 24 to 50%, different estimates, and these are the citations down here, with green buildings. They can help with these reductions. CO2 emissions, we can reduce by 39%. So that's the same as this one. Waste output, solid waste, 70%, so that's more than the previous impact slide. And water use, we can get down by 40%. So a lot of good, humongous savings and impacts we can have on this thing that takes up so much of our energy use and our environmental impacts. One of the big concepts, renewable energy and energy efficiency. So energy efficiency is defined in various ways. One of my favorite ways, though, is the goal is to accomplish the same tasks and functions as before while using less energy, doing more with less. And so we'll kind of use that as a guide as we go through some of these examples. And renewable energy, while we just saw solar on there, they're naturally replenishing, but the flow is limited. So they're virtually inexhaustible in duration, but limited in the amount of energy that they're available in a given moment. So, other generators have to help them when there's not enough sunlight or enough wind. And obviously it includes various types. Energy efficient lighting. So here we have, some people already mentioned day lighting. And this is to help reflect the light evenly throughout the room. So it's not just about energy efficiency, right? It's about the atmosphere of the room, how this environment is for the occupants of the building. And then we have LED lights here. And we also talk about how, obviously at UCI there's a lot of remote sensors. So when you walk into the building or not, the sensor goes on and off. And having individual control over your light. So task lighting, if you have a desk and it's a bunch of offices, why do you need a lot of overhead lighting? If you have task lighting and then remote sensors, that can reduce energy efficiency and also make the occupants feel like they have control over it. Because a lot of times when it first started happening in my mom's office in DC, it would always turn off on her. You have to move her desk back every time, her chair back all the time. And now, but if you have your own little task lighting, you still have control over that, so you don't have to be moving around all the time. So it's about your own personal freedom and energy efficiency at the same time. Alternative transportation, like you guys pointed out. And this obviously helps with lots of things, reducing CO2 emissions, reducing smog, ground level ozone. So we have a team in the class right now working on creating an idling video, an educational video for the bus drivers and the public. So when you idle for more than 10 seconds, right? 10 seconds, it's more efficient for you to turn your car off and just wait. And there's a policy on UCI's campus, but barely anybody, it's also 5 minutes instead of 10 seconds. But that barely anybody knows about or follows, and it makes the air quality at the ground level for you walking by or you running on your morning run much worse. So having alternative transportation is hugely helpful, and especially one with an idling policy. It also, increases. A lot of people find that if you use public transportation in major cities, it has public health benefits that just end up coming along with it as sort of like a snowball effect. Because you have to walk from your car all the way to the public transit, which usually isn't that far, but it's better than driving to your office, getting out, walking 10 feet to an elevator, going up and sitting down again. So public transit actually has a hidden benefit of public health that they've been finding in a lot of studies. water efficiency, as we were talking about. And it sounds like UCI, I was going to ask if UCI has the waterless urinals, but since somebody mentioned it, I'm assuming they do. So with water efficiency programs and things like this, using harvested rainwater that we were talking about earlier, gray water to flush the toilet. So that water is called gray water. If it's water that's been used before and you're not going to be drinking it, then why can't we use it in the toilets or watering the lawns? So that's non-potable water or gray water because you can't drink it. And that can save up to as much as 50% of water of energy for water use. Water efficiency can increase it. Recycling. So obviously what Bluebird was talking about earlier, of waste that we have in our buildings, and also within purchasing. So what kind of products do we buy? This category isn't also just about recycling materials, but also what we buy, the food we buy, the furniture, the products, the glass walls, daily uses, such as sticky notes and pens. And then there's this, Professor Matthews sent me this video. But she's talking about products that actually are naturally occurring and that you can use in architecture and potentially have a conversation with the natural environment. So when you think about purchasing and products and things, we're talking about sort of the base level green building, but there's a whole nother vision of what it can be in the future too. Now I feel like my next slide is going to be really boring, okay, because it is. Joint use, energy efficiency. So this is efficiency, maybe not in the energy sense, but in the efficiency sense, doing more with less. So how many people have voted at a local school? You know, almost all local schools combine up with cafeterias and multi-purpose rooms. This you can get credits for in a green building. Point two, the interconnectedness of the built and the natural environment. So two great examples of this are things we've talked about, green roofs and daylighting. And also, and like we were just talking about, regenerative buildings, or buildings that are completely integrated into the natural environment to such an extent that they're helping the environment that they're in around them, like what that woman was just speaking about. So yeah, some green roofs, like at the U.S. Green Building Council, the top of their roof is just plain white, and it reflects the sun off, so that which also helps reduce the urban heat island effect. So that how many people know what the urban heat island effect is? So in most, inner cities, it's hotter than it is in the country. If you just hear any weather report and you hear downtown Chicago versus the suburbs, or DC versus the suburbs, it's always warmer because of all the concrete and the black concrete, and it's a concentrated area, and so it's always warmer there. And so to try to even that out and get back to the natural temperature, green roofs are one way to help that. And you can have a flat, we always heard that albedo, I forgot the name, is it albedo? Yeah, roof, or just throw some mildly alive things on there, organisms, or you can have a full-blown green roof with vegetables and plants. So here, this slide was prepared by one of your fellow classmates who's very passionate about green roofs. So here we have a list of all the benefits here. It takes waste space and makes it useful, so it's space on the roof that nobody's using. I mean, sometimes they have lunch areas up there in big buildings. Reduces energy costs and natural insulation. The urban heat island effect we were talking about, it creates a natural habitat for butterflies and animals and plants. And then it minimizes stormwater runoff, and that's another key thing for a lot of planners. Anybody in the planning department here, or just sustainability in general. When it rains in cities, if you don't have permeable surfaces or areas that can capture that rain and clean that rain, then the rain just goes onto the streets, onto the concrete, and into local waterways or in streams. And so the more greenery you have, the more permeable surfaces, so surfaces that the rain can get through, the better it is for the natural environment at large, and also for city planning. You know, they don't like to have massive floods on the middle of the streets too. So a lot of people are invested in reducing stormwater. So another example of the interconnectedness of the built and natural environment using daylighting has a huge impact on environmental quality, health, and learning. And this reduces energy costs and improving concentration and performance. This has been found in studies. And sometimes you can have adjustable blinds to help reduce glare with daylighting. And how many people are taking environmental psychology right now? I think next week, your lecture will be about natural environments. And one of the readings that you have is a big thing that talks about how important it is to have a view of nature from a building. And it's about hospital gallbladder patients, people who all of them had gallbladder surgery, and all of them were in the same type of hospital room, so it was a perfect sort of experiment to set up. And all of them had the same doctor, and then only half of them, I think, or so, had a view of an outdoor area, and half of them didn't have a window. I think that the outdoor area had a tree. And so the people with the outdoor area, and they studied them before and after, had less post-surgical complications, asked for less pain medication, and were oftentimes released earlier from the hospital. So that was one of the big studies about how nice it is and important it is to have daylighting and natural views from buildings. So point 3, the built environment and its impact on public health. So a critical piece of understanding buildings is how it's part of a larger system, and how to make decisions about that building at the building level and how it's going to impact the community and the people in it. You know, if you have more recycled content in a building, there will be less local waste, so your waste diversion rate will be high. Local materials, if you're buying local materials, which is one of the requirements of green building, you're also supporting local businesses. So again, we see a little touch of the triple bottom line. Mold prevention is a big issue, and this is part also of green building, one of the social parts of that triple bottom line that we were talking about. So if you have more ventilation, you know, as opposed to the sick building syndrome, it can relieve humidity by below 60% with adequate ventilation, and inhibits mold growth. And of course, mold growth can have serious health concerns. Similarly, low-emitting materials. We talked a little bit about this earlier, but not that much in depth. So low-emitting materials are materials that have, I think I'm going to go into it a little bit more later, but volatile, no to very little volatile organic compounds. And so these are naturally occurring, and they can also be man-made. And the man-made ones indoors, the impact of them is 10 times what it is out of doors. So the danger of them indoors is a lot more poignant than it would be outside. And so having materials on your tables and your furniture, how many people have familiar with sort of the new car smell, you know, when you get in a new car? It has a pretty potent smell, right? And that is actually the smell of volatile organic compounds. So it's not a good smell. Don't breathe it in. And it has sort of long-term negative health impacts, but not, you know, again, not like, you know, once you breathe it in, you're going to die, you know, or something. But they're not good, and so green building has taken this into account. And so when you walk into, for instance, when the U.S. Green Building Council or any building that's built on this campus, if you walked in the day that they opened it, maybe they were painting the day before, you could walk in that building and you wouldn't smell anything. It wouldn't smell like anything, and you'd be comfortable to work. You could sit down. It would be okay. Oftentimes, when construction happens, you have to wait 3 months to move the whole office in, which probably doesn't save money. Probably costs a lot more for that waiting time. And it's all to let, you know, air it out and let the compounds work their way out. So this is in ceiling tiles, wall systems, furnitures, and obviously can have an effect on respiratory issues. So some other things that you guys didn't list when I asked you in the beginning about the triple bottom line in green building are acoustics and thermal comfort. And so, you know, I think we've had some issues, at least in this class, about the silly lights up there, but that's a different kind of comfort. But acoustics in a learning environment in almost any building are really important. So if you have good ceiling tiles, ductwork, quiet heating and ventilation systems, appropriately placed vents, you can really have a big impact on creating a more productive learning environment in educational settings and in a workplace. And similarly, comfortable indoor temperatures can enhance productivity and keep students alert. And again, not to reference environmental psychology so much, but that's what I study. So in that class, you guys might have read a study about acoustics and student learning. Dr. Stokels talks about one with airplane noise. There's another one in New York City about a train driving through and the effect on student learning depending on where the students were that quarter. Their reading levels would go down if they were closer to that, because it's really, I mean, what they say is, and what I think they're measuring in neuroscience right now is, you can't hear yourself think. It's like the experience of not being able to hear yourself think is when there's too much noise going on around you. So very, very critical. So you see, as usual, the triple bottom line of sustainability with green building is a huge, huge aspect. And here are some statistics. So with high performance lighting, when we were talking about task lighting, it can enhance productivity by 6.7%. Individual temperature control. So when I was growing up, you know, you guys have a pretty temperate climate, but it would be freezing in the spring quarter of the second half of school for me. because they would just pump the air conditioning so hard that it would just be frozen every single day. And I literally think to the point of distraction of me not being able to learn on numerous occasions. And I was wearing plenty of clothes. So yeah, the individual temperature control and being able to have control over that can increase your productivity by 3.6%. And obviously having better indoor air quality so that issues with asthma. I mean, asthma is a huge issue in our country. There's a report that students in America miss approximately 14 million school days per year because of asthma. And if I asked you, which I won't because I'm asking you tons of questions, I bet you probably half of the class has some kind of asthma-related issue or something. I'm not sure, but it's one of the hugest things. And so if you want students in school more, you want them to learn better and be in school and being active in their learning process, then you could get, if the indoor air quality is good enough, then they should be able to attend school. In my middle school, I had a friend who couldn't come to school because of the air quality. His asthma was so bad that he had to be homeschooled for the 3 years of middle school. It was horrible. Yeah. So I think they're working on that school now, finally. And so finally, the environmental bottom line we talked about, but here's the economic bottom line. And we talked a little bit about the economic parts of green building, but one of the key concepts that some of you guys have touched on maybe a little bit, but not entirely, is return on investment. I mean, this is a big, big concept in sustainability in general, and probably a lot of you in your reflections talked about the obstacles to implementing some of these issues and solutions. Oh, it costs too much money. If you're going to work in any job in the environmental world these days, you need to know what ROI is, because that is your argument, that is your go-to. If they say, oh, so solar panels, that'll take 15 to 20 years to pay back. That's what they used to cost, 15 to 20 years to pay back. Now it's about 10 to 12 years. And so it's just, as the technology gets better and the prices decrease, the return on investment of how much you spend up front and how many years it'll take for you to make that money back and then start making money on what you've installed is the return on investment. So yes, green buildings do cost more. That is a commonly heard phrase. But the return on investment of them and the resale value of them in the real estate market is huge. And so just when you're thinking about any sustainability product or trying to sell anything or your jobs, always think about the return on investment and try to always have that number handy if you go to a public engagement or if you're working the table at your new job or something. So point number 4, sustainable building as a model for financial security and profitability. So as I was just saying, reduced energy and water costs in the medium and long term. Here are some statistics. On average, actually, a green school can save about $100,000 in direct savings per year. And so that, that kind of money can go to teacher salaries, buying school books. I mean, I know California is having a really big issue with this right now. So that's a lot of money that could be going to other areas. Here are the results of another study that looked at 30 schools. 33.4% of average direct energy savings were found, 50% of indirect, and 32.1% of water savings were achieved in these 30 schools on average. These savings and this kind of, if you really see a strong economic bottom line, it's generally because the process worked. So the green building process is not just about, slapping it all together. It's a very extensive, exhausting sometimes process, but it's become such an industry driver that people are invested in working with different people from different areas, engineers and architects. And so to get really, really good savings, you should be motivated to work on a team. And so that's where systems thinking comes in. And so they call green building is about an integrated design process. If you're not starting from the design phase, so this is when you're drawing the blueprints, if you don't invite everybody in the room in that same time, you won't get the kind of results that you want in the end, because maybe the engineer didn't listen to the architect, or the water manager or the building owner wasn't able to do that or didn't want to fund this. So you need to have everybody in that room if you want to achieve really, really good, really high levels of green building certification. And this is kind of demonstrated by what they call a lead charrette. So they have everybody come in the room. I was part of one once. I was an intern in AmeriCorps, and I did the waste stream audit for the building. And we had the building owner who was dating the lead AP, which was weird. And then we had, and so they were just like ready to, they were going to do anything they wanted to the building. And then the engineer and the HR manager, who was this grumpy old woman, and it was just like all of these different people in the room had to talk to each other and work on this project to make it happen. And like I said, from the early stages are important. So here is an image of sort of the different players, at least on what we thought of on a university campus. So you have, facilities managers, landscape architects, because it's not just about buildings, but the built environment. Interior designers, huge, huge impact. The impact that these people can have on energy efficiency and the atmosphere of the space is huge. Alumni, this is one example I was telling Mr. Brittell in one of our meetings. Stanford, some of the Ivy Leagues are a little stuffy about green building, I think. They want to build their own rating system. They want to say, we did this, and we're not going to use LEED, which is fine if they're going to do something really neat. But at Stanford, there was one alumni that said, okay, I'm going to fund this whole new business school. I'm going to give you billions of dollars. And he's like, but it has to be a LEED platinum building. And they were like, oh, they're all disgruntled because they were coming up with their own rating system. And then you have engineers in the room. So this is what you guys could do at UCI, to push them to do more. Federal and local state governments. If there's a policy, like the UC system has a policy that everything has to be LEED silver for new construction. Yeah, so any newly built building has to be at least LEED silver, which we'll talk about in a minute. So there's just a lot of different players here. Students, you guys can advocate, be part of this process, sit in, do the waste stream audit like I did. Here's another example of systems thinking. So LEED addresses the complete life cycle of a building. And for all of you guys doing your individual design projects, you should definitely know what a life cycle analysis is by now. And so it's a system because we're talking about the development of the materials. Where do these raw materials come from? Where were they acquired from? Where are they shipped to? How are they used in the building then? How are they maintained in the building? If you have to replace a carpet square or have to buy a new energy appliance, what kind of appliance are you going to be buying? So that's the use part of the life cycle. And then the disposal part. So what do you do with these things afterwards? Waste management. Where are they going to go? What's going to happen to them? How much are you going to be recycling or not? And so your design project, as you all know, has to address all three of those. And so here are all the different rating systems that they've developed for homes, neighborhood development, commercial interiors, which is what the Environment Institute team is working on, new construction, schools, healthcare, retail, so if you're a restaurant. And so these last three are all about existing buildings too. And that's, we're predominantly talking about new buildings today and how new buildings are built, but existing buildings are the majority of buildings in the country, so we really have to think about how we're going to renovate those and work on those. So this is Sidwell Friends. This is where the Obama children go in DC, and it's one of the most famous green schools. Well, it is the most famous green school in the country. I'm pretty comfortable saying that. And it's LEED Platinum, and they have, if you are ever in DC and you want to get a tour, you can set up a tour, and a middle schooler is forgiven from class. They're allowed to go out of class, and they walk you around and give you a whole building tour of everything. And they all know everything about the building. I mean, it's amazing. They walk down the hallway, and they're like, oh, let's see if the solar panels are working. There's like a display on the wall, and they punch the wall. I mean, it's middle schoolers, so of course they want to punch walls, It's like, and then you get like different numbers when you punch the walls of how the solar panels are working, and they interpret them for you. And then they were telling us about the bathrooms when you flush the toilet, and it turns blue if the rainwater cistern isn't working. So if the water that they're collecting and the non-potable water that's flushing the toilet for them isn't working, they get an indication because the engineers in the design phase way back when made it a learning experience for these students. So they'll be like, excuse me, teacher, what's going on with the rainwater today? Something's not, you need to fix that, And they start nagging, and it's like this whole system. It's amazing, and they're really cute, so you should watch the video. And obviously they have a cool green roof too. Here's a LEED Gold existing building, the Empire State Building. And then USGBC headquarters is a commercial interior similar to what the UCI Environment Institute has certification for. And here, I mean, this is one of the coolest parts of the tour. This is sustainably harvested wood, but it's from the bottom of the Mississippi River. So, back in the day, like when you saw images or old videos in your history classes of like barges of like wood going down rivers, and then some of that wood would fall off and it would just like go into the water. And nobody thought about it until maybe green building came along. And so they dig this wood up, and there's a lot of it because it wasn't a very efficient way to ship wood, I think, and dry it, and then they're using it in buildings now. So it's really, really quite beautiful. And they have a great tour that you can walk through the whole tour of their space online now. So you should check that out. It's pretty neat. And like I was just saying, commercial interiors. Here's the UCI Environment Institute. If anyone wants to input the tour that these well, these two are part of the group here, are creating, let them know. But they have some pretty cool features, and online you can also check that out about the different features of the Environment Institute. So concept number 6, sustainability certification and rating system. So I have obviously been talking about LEED quite a bit, but there are other ones such as Green Globes, Energy Star, CHIPS, which is California High Performance Schools, and National Association of Home Builders has a rating system also, or certification program, I should say. It's not a rating system, but a program. And these are just important because you need to check yourself, you need to grade yourself. There's only one university, I think, that I know of in the country that you don't get grades at, and it's pretty hippy-dippy. I visited a friend there, and they grade themselves. And that, I mean, would you really trust somebody to grade themselves? The same with green building. Would you? Come on. It's like, did you really do it? Prove it. So the U.S. Green Building Council has 4 levels of LEED. Like I was saying, the UC system requires that all new construction be LEED Silver. But as you might notice, on UCI's campus, we kind of go for the gold and the platinum. We're aiming for that oftentimes. Mr. Brittell was just telling me that one of them, while we achieved LEED Silver, this is how competitive this marketplace is. They're like, well, wait, we have a few more points. Maybe we'll get to gold. And something's been held up for 3 years because they're so motivated, this design team, these group of individuals that have from different backgrounds to work together, that they want to push it to the max. They want to get it all the way up there. And so this is it's kind of like a scorecard, So you have your water efficiency, energy and atmosphere, materials and resources, indoor and environmental quality. And the innovation in design is actually part of sort of giving those green building tours. If you come up with something really innovative, you can get more credits. So this is the report card. There's tons of USGBC chapters. It's a huge movement, so this is how it's sort of an industry driver. There's millions of people on the local level. The USGBC LA chapter is very active, and these people are advocating for policies and changes across the country. Some other examples of how it's an industry driver, the Labor Department has a Green Jobs report, and so the Obama administration was announcing some things with that Green Jobs Act that didn't go very far. But anyway, if you look at Labor Department statistics, environmental jobs are still on the rise. If you want to be an engineer, environmental engineers will make a little bit more, and they're more in demand right now. So there's just a big trend in this direction still. In the international markets, I was just at a wedding where my friend's marrying a man from South Africa, and he works on South African green building. They have a program there also. So there's millions of countries that are moving in this direction also. This is one of Brad Pitt's favorite organizations. So the 2030 Challenge is architects have put it up to themselves. So again, an industry driver. There's a competitive spirit about this industry, that they're aiming for carbon neutral buildings for all new construction and big renovations by 2030 to be carbon neutral. And they have steps on the way to achieving those. And they say you can accomplish this with sustainable design strategies, on-site renewable, and or purchasing, so on or off-site renewable, and of renewable energy. And wait, that's 2 things. So accomplish this by sustainable design and on-site or off-site renewable energy. So another example of how the industry is moving, this is for green homes. As of 2006, they say 50% of builders are focusing their attention on green building issues. Between 40 and 50 of the homes built in 2010 are expected to be green. That's the National Association of Home Builders. For education facilities, this is why it's so important that your campus is doing, that the UC system and our campus is doing cool stuff. It's a huge part of the construction market. This is the construction market in building. And education is one of the largest things that are continually, well, most of the time with budgets, budgets permitting, building. So of the 20 largest school districts in the nation, 80% have committed to green school construction, including LA Unified School District and the Chicago School District, lots of major ones, and 95% have made this commitment in the last 5 years. So you can see just how much of a catalyst has been happening in this area. And here we have LEED projects in higher education. They're on the rise also. Here's an image of a dream green campus, which with obviously some marketing in there, but we're dreaming up what are all the elements of a green campus could be. It was a blast out to the whole entire employees, and everyone sent there what they thought should be on their campus. And the Princeton Review, who developed a green schools guide with the U.S. Green Building Council, did a survey and found that of college applicants Oh, I forgot there's an iClicker. I'm like, why are you guys moving? 68% of them were looking for a green campus. So while that might not have been their deciding factor, you know, I know it's like cost and location mostly, a lot of them said it was important to them. Okay, so now we're going to move on to a little bit of UCI. I'm just doing a very, very brief thing here. So the campus opened in 1965 and only had an inner circle and a halfway completed park, 9 buildings and a dirt road. So by 2005, the campus had 200 buildings. I don't know, there's probably more now. Maybe Mr. Brittell knows. And uses most of the university's 1,500 acres. So that's an image of your beautiful campus. Here's some statistics about what we found on average campus buildings use. I think that might differ, though, obviously campus to campus. So without further ado, I'm going to turn over the presentation to Mr. Brittell to talk to you about what's happening at UCI.
Okay. It's pretty exciting for me to be here since I was here before this building was built. In fact, before this building was built, there was another building on this site designed by Frank Gehry, who, if you follow architecture's up there, he's pretty well known internationally. And so that building was about 20 years old, and it was approaching the end of its useful life, and it was torn down, and we put up this building in its place. So it's kind of exciting for me to be here. So you see here is an aerial view of the campus taken a few years ago. So what is LEED? Well, we've heard all about that for about the last hour, so I won't go into that. It's a leadership in energy and environmental design, and it is developed by the Green Building Council. We saw these statistics earlier, so I'm not going to repeat them, other than to say that what it adds up to is that buildings have a large impact on the environment. The environmental benefits are designed to enhance and protect ecosystems, improve air quality and water quality, reduce waste, conserve resources, reduce operating costs, which is very important to the campus, enhance asset value, improve employee productivity, optimize life cycle economic performance, improve air, thermal, and acoustic environments, occupant comfort and health, and minimize strain on local infrastructure and contribute to the overall quality of life. In 2004, the regents of the university mandated that new construction meet the LEED certified as a minimum, with the desired goal of meeting LEED silver. In 2009, that was changed to require LEED silver as the base and LEED gold as the goal. Another feature of the policy is that all buildings are required to exceed the California Energy Code, which is called Title 24, by 20%. Now, the university has been doing that for the past 20 years, so in a sense, we've always been pretty green. But now, while the requirement is for 20% minimum, the goal is to achieve 30% or better as a standard. And there's one building on campus, Gross Hall, that has achieved 50% performance over and above the Energy Code. Here you see a LEED scorecard. This is for the Anteater Instruction Research Building, which is right over here. This project was our second building to achieve LEED Gold. But basically, we achieved 42 points, which was 2 points more than was needed for gold. So earlier it was mentioned that does everyone agree with the statement that green buildings are more expensive? Everybody? Guess what? They're not, at least not at UCI. All of our buildings that have achieved LEED certification have done so without any extra budget. And in fact, all of them so far have achieved gold or better. So we have achieved a high level of sustainability without additional funding. I'll just go over briefly some of the features that were for this building. We received credits for site selection. Basically, by virtue of the fact that we're a campus and we're within the Irvine community, we meet all of the requirements for site selection. Urban redevelopment credit was achieved. Alternative transportation, due to our proximity to all the bus lines, we qualify for that credit. Parking capacity, carpooling, reduced site disturbance. We built on an existing footprint of previous developed space, so we qualified for that. Stormwater management and landscape to reduce heat island effect, and roofing to reduce heat island effect. The building we used recycled water for landscaping, so we earned those credits. And the building met both credits for water use reduction. We talked about water use reduction earlier. All of the buildings that have gone through LEED certification have achieved 40% or better water use reduction. Somebody mentioned waterless urinals. I think there are only 2 buildings on the campus that actually have waterless urinals, and opinions are mixed as to whether that's a good thing or a bad thing. A lot of people don't really like them. Some people feel that there's a smell associated with it, but the main reason that we don't use it is economic. They're just too expensive to maintain. There's a cartridge in the bottom that takes the place of the water in the trap, and they're very expensive to replace, and they have to be replaced often. So the university has settled on ultra-low flow urinals as the preferred method of reducing water. It uses 1/8 of a gallon per flush. And that's one of the ways that we enforce water use reduction. Another way, all of the faucets that you'll see in the newer buildings have flow restrictors in them so that they basically put out less water. So there you have it. In the energy and atmosphere category, this building achieved all 10 credits available. And to be honest, I don't know how they did that, but and the reason I don't know is because that the engineers that did that won't tell us how they did it. That's proprietary information, I guess. But we did manage that, and I can tell you on some other projects how we did that. Another credit that the university requires is additional commissioning. Commissioning is the process where you go through to make sure that the systems operate the way that they were designed to operate. They operate in an efficient manner. Some on the other side, materials and resources, construction waste management. This project diverted more than 75% of the construction waste from landfills, and that's a university requirement for all major construction projects. This project also the materials used in the project have more than 5% recycled content, and 20%, more than 20% were manufactured locally, and locally, according to the Green Building Council, is within 500 miles. And the project used certified wood, which means that the wood that was used was harvested in a sustainable manner, and they have paperwork to prove it. It's called a chain of custody. On the environmental quality side, we got credit for an indoor air quality management program during construction and before occupancy. What that means is that when the building is under construction and the ductwork is exposed, it's covered up so that dust and dirt does not get in it, which would then later be flushed out into the building, and then you'd be breathing it. And then at the end of construction, before people move in, the fans are turned up to, I forgot the volume now, but basically it blows all of the VOCs out of the building before people come in. So it smells nice. There are several credits for low emitting materials, adhesives and sealants, paint, carpet, and composite wood and agri-fiber products. Irvine is within the South Coast Air Quality Management District that includes Orange County, LA, and a few other areas. And LEED has used the standards from the South Coast Air Quality Management District in formulating their requirements for indoor air quality. So anything that we buy in Orange County in those areas already meets sustainable standards. So we've been sustainable around here for quite a while. Another credit was thermal comfort, and that has to do with the design of the mechanical systems. Then the last category is innovation and design, and this is kind of like an extra credit category. You can get credits for exemplary performance on other credits where you go over and above the requirements, and you can also get credit for innovative things that you do that aren't contained in the rating system. One example is the campus has a landscape planting and management plan called the Green and Gold Plan, which promotes sustainable landscaping. So we were given credit for that plan on all of our construction projects. Another part of this process, maybe I should back up. When the LEED policy went into effect, there are versions of LEED, and the version of the new construction category was called version 2.1. That led to version 2.2, and now we're in version 2009. It's kind of like a building code. They keep updating it every so often. But during version 2.1, the Green Building Council offered a pilot program on ways to streamline the accreditation process, because the process is expensive. It costs thousands of dollars to actually get that plaque, just to have the Green Building Council review and certify your building. So campuses are always short of money, so they gave us this option to streamline some of our credits. And the ones that you see highlighted on the screen are the credits that UCI achieved as they're called. We call them prototype credits. What that allowed us to do is apply these credits to every construction project, which kind of makes them free in a sense. And so we achieved a total of 17 prerequisite and credits that were applied to a variety of projects. Since the version 2.2 expired, the prototype pilot program went away, morphed into something else, and so we're working on that as well. Now I want to talk about how buildings are built here at UCI. There are many different ways to deliver a construction project, but the most common one historically has been the design, bid, build process. In this process, the design professionals prepare construction documents, and then those documents are sent out to bid, and contractors bid on them, and then a contractor is selected, and the project gets built. At UCI for the past 12 years, we have been using the design, build, delivery method. Now what you see at design build is the project scope is identified and the budget is established. Then design build teams are pre-qualified. We advertise and they send us their qualifications, and we select usually 3 or 4 teams that are the best qualified to bid on the work. And what they do, rather than bid on plans that have already been prepared, they prepare a design that meets our project scope and our budget. And they basically, it's kind of like a design competition, but it also involves money. The objective of this process for the university is to save time. And when you save time in construction, you save money. So it makes it more efficient. Buildings are delivered sooner and they cost less. And we take that savings and use it to enhance the building. Once their proposals are complete, we evaluate them in a kind of a blind process. The evaluation team does not know who they're reviewing, and it's very it's as objective as it can be. And at the end of the process, we come up with a design that has the best value for the university as opposed to the lowest cost. An example of best value, during the design of the Gross Hall project, the winning contractor offered the university an additional floor for the building. It's like 25% more space than the program called for. It's like, how can you turn that down? They also offered us a LEED Gold, guaranteed, as opposed to LEED Silver. So those enhancements are what add to the value of the building. And so we get the most for our money. This slide is the Palo Verde housing expansion. Does anybody live in Palo Verde? Anybody? No graduate students? Sorry. This was our first LEED certified project on the campus. And it came in at gold, and everyone was very excited. So that kind of got the ball rolling. Here's our second project, and it said, well, since we got gold on Palo Verde, how about we get gold on this project? And we worked hard with our design team, and we were able to achieve that. The glass is very sustainable. The glass is a insulated glass unit, which means that there is a layer of glass, then an airspace, and then an inside layer of glass. On the inside layer of glass, there is a coating that rejects heat, and it gives you a little bit of a green tint. And that glass is kind of a standard on the campus, and it reduces, it basically acts as an insulation device. So, you know, it just looks like glass, but it's more efficient glass. The roof of this building, and almost all of our buildings now, has a very reflective white roofing material. It's made out of thermoplastic. If you go up there during the day, you might want to bring some sunglasses because it'll blind you. But it also reflects a lot of the sun's heat, and by doing that, we are reducing the need for air conditioning. So our air conditioning systems are smaller, therefore they use less energy. So it kind of trickles down. Here are the projects that are currently under LEED review. Biological Sciences Unit 3, this building, Engineering Hall, the Social and Behavioral Sciences building, Medical Education building over on the College of Medicine campus, the Arts building. All of those are in the LEED version 2.2, and all of those buildings are complete. The last three buildings, Verano Place Unit 4, the Newkirk Alumni Center, and the Gavin Herbert Eye Institute are all under construction right now. All three of those will be evaluated under the LEED 2009 rating system. Here's the list of the buildings that have been complete. This list does not include Palo Verde. I accidentally left that one off. But the Student Center expansion, the Recreation Center, Brent Hall, Humanities Gateway, the Clinical Lab building, which is on the Medical Center campus, and Gross Hall. And as you can see, two of them, Humanities Gateway and Gross Hall, both achieved LEED Platinum. So all of the ones that were in the pipeline, we're looking for ways to make those Platinum too. And here's a map of the campus, just showing you where the buildings are located. So if you are walking around, keep in mind these buildings are sustainable. One of the things that Ms. Davis and I were discussing when we were preparing this presentation is that what does a sustainable building look like? It looks pretty much like any other building, really. It's very hard to tell by looking whether or not a building is sustainable. But for instance, the carpet is sustainable. It is recyclable. It has recycled content. Some of the newer buildings use carpet tile, and now carpet tile is manufactured so that it can be 100% recycled. The manufacturers take that carpet back when you're done with it. They grind it up and make new carpet out of it. So that's called cradle-to-cradle sustainability. Beyond LEED, I highly recommend the university's website, sustainability.uci.edu. If you go there, you can find out a lot of information about what the campus is doing. There is a list of green actions that the campus is pursuing that includes actions that have been achieved as well as ongoing and future actions. Our central energy plant is very sustainable. It's one of the more sustainable ones in the western United States. We recently constructed a cogeneration plant. The cogen plant takes waste heat from the boilers and reuses it to provide additional energy. So it's basically recycling waste heat. And the cogen plant is the reason that we were able to achieve all of the energy, or the EA Credit 1, the 10 points that I mentioned earlier. That's the mechanism that we use to get all those points. LEED calculates the cost of energy for buildings as the measure of how you achieve energy efficiency, and using that free energy from the cogen plant is what basically enhanced our score. Transportation is another key feature at the campus. The campus has a transportation management plan that has won awards and has also given us 2 LEED credits on some of our newer projects because of its sustainability features. Campus housing is always striving for energy efficiency. We're in the process of remodeling some of the dorms to be more energy efficient. And campus dining is also looking at ways to be more sustainable. I think, has anyone seen the Weigh Your Waste? Yeah, okay. Weigh Your Waste and sustainable food, like farming and things like that. And you can read a lot about this on the university's website. Within the UC system, we're very high. I think Davis has more platinum buildings, but we have more total LEED certified buildings. And when we're finished with the buildings that are in the pipeline, I think we're going to be pretty much at the top of the chart. Has anyone heard the phrase UCI stands for under construction indefinitely? Well, now with the budget situation, it stands for under construction intermittently. There aren't many large construction projects on the horizon at the moment. The next project to be built is going to be a building for the School of Business.